Okay, probably this is the right time to start. So before diving into the technical details of the session, let me introduce you to the panel today. So myself, Anshul Agrawal, I am Senior Manager Product Development for BMC AMI Data for IMS set of products. I am primarily taking care of backup and recovery utilities and fast path utilities. And with me today, we have two gentlemen, Rupak Devaroy, he's a Principal Product Developer who is also an SME for backup and recovery utilities. And he will be doing the technical deep dive of this new feature that we are introducing today. And we have Yogesh Jarekar, who is a lead quality automation engineer responsible for quality assurance of backup and recovery utilities. So whenever we talk about IMS, the one term which comes to our mind is the resiliency. And what exactly resilience means? This is the capacity to withstand or to recover from any difficulties. And when we talk about resilient systems, the three main characteristics are it is highly stable, which means that there is less chances of any kind of issues or errors. It is highly secure from any kind of vulnerabilities or attacks. And last but not the least is robust validated recovery processes. So when we talk about IMS subsystem, we know that it is a very robust recovery process, whether you talk about IMS recovery or IMS database recovery. And when we are saying that IMS is so resilient, why we need to do anything? Obviously, things have changed over the years. Recently, there is a lot of regulations which is forcing organizations to make change. One such example is DORA compliance, where you need to prove the recoverability of all your IMS assets, whether it is IMS subsystem, IMS database, or any other recovery assets like recon dataset. And then obviously you want to avoid single point of failure and lot of incomplete solution which is still exposed, because a lot of your disaster recovery processes has been established 20-30 years ago, and obviously things have changed in last 20 years, and in last 5 years things has drastically changed. So it's important to revisit your disaster recovery procedures and fill any gaps that might be present there. So these are the three main points to consider. And when you talk about your recovery, these are the points to consider. The first one is the recovery point objective. That is the maximum time or the maximum amount of data loss you can tolerate from the time point of failure. And obviously this window is shrinking day by day. The ideal is no data loss. And the second main point is recovery time objective. From the point of failure, how much is the maximum time you can tolerate to recover your IMS subsystem, recover your databases, recover your any other recovery assets. And both these objectives now tending to zero. You cannot afford any data loss, and you would like your systems, your databases to be back up and running as soon as possible. It's of paramount importance that you align your recovery strategies and you take inputs from all the stakeholders, which is important for your recovery scenarios. And do visit your existing recovery procedures because they will definitely need a change from when they have been established 5, 10, 15 years back. Because obviously things have changed in recent past. And in this particular session today, we know that when we talk about IMS and we say that it's very resilient system, it has the ability to recover from any kind of disaster to a point in time, whether it's IMS control region or your IMS dataset. But we know that for recovery of your IMS database and recovery of your IMS, subsystems, the most important dataset is the recon dataset, which is keeping track of all the log datasets, related to a recovery of IMS databases. So it's of paramount importance to, recover your recon datasets from your last backup and to have the ability to recover it to a point in time, whether you want to do a forward recovery or you want to do a backward recovery. It's very similar to the way you do point in time recovery for your IMS database. So you can treat your recon dataset as a database because it's a VSM file. And then you can do a point in time recovery of your recon either forward recovery or the backward recovery. So from this point onwards, we will be talking more of how you can do it with the new feature that BMC is offering as a part of BMC AMI data for IMS backup and recovery set of solutions. So here I will invite Rupak to take us into the deep dive of this new feature. I'll hand it over to you, Rupak.
Thank you, Anshul, and good morning and good evening, everyone. And thank you for tuning in. I am Rupak Devroy. I work at BMC in the backup and recovery product development. We are really excited today to talk about a new feature we added to our recovery product recently. As Anshul mentioned, this is about the ability to recover IMS RECON datasets to any point in time in the past using logs. That's the key, logs. Next slide, please. Okay, so first let's take a look at how traditionally recon recovery is done today. Normally what users do is they take frequent backup of their recon datasets, and in case of any problem, they roll back to one of the earlier backups. Like in this diagram here, a backup was taken at time T1, and then another backup taken at time T2, and sometimes later at time Tx, we discover there is a problem or some kind of inconsistency in the recon. And further analysis is done, and we found that some process ran at time Tr, which corrupted the recons. So we have to restore our recons to time Tr. However, our most current backup was taken at time T2, so we can only go back to T2. So when we do that, we lose all the updates that took place between T2 and Tr. So what it means is before you can put that recon back online, you may have to go back and manually make a lot of adjustment to the recon so that it's in sync with the databases. So that's the problem we have today with when you recover using backups. So let's see what we are doing new here. Next slide, please. So what do we do with this new facility is we create a log record every time there is an update to the recon dataset. By update, I mean insert, delete, or change. Okay. So we create these log records when there is an update to the recon, and then we also, along with the log record, we save all the images and after images of the record and save them in a log data set. These log data sets are not the normal IMS SLDS. These are totally separate log data set we create when we manage them ourselves outside of IMS. So in the same scenario in the earlier slide, you took like backup of the recon at time T1 and T2 and at time Tx. We ran into some problem and we want to roll back to time Tr. Now here, since we have log records for every update that has taken place to the recon, so we can just take the current recon and back out all the updates starting from time Tx, go backward up to time Tr. Basically apply the log records from the most recent and going back to older previous time or earlier time. So that way we don't lose any updates. So that's what we are doing here. In case your recon is not readable, say for example, there was a cyber attack or something and it messed up the recon completely. In that scenario, if you have a backup, say you have a backup at T1 or T2, so we can take that backup and apply the logs starting from T2 up to Tr and actually rebuild the recon data set. So we have both options here. Either back out the existing one or we can rebuild the recon data set using an earlier copy. So this is what's done in this within this feature. So let's look at how we generate these log records. Next slide, please. So this log generation process, it takes place while your online system is running, or if you're running, say, image copy or recovery, maybe the database is authorized. So it's running where things are live. So you don't have much room to do any processing that will take a lot of time. Basically, time is of essence here. So whatever you do, the process to create those log records, that has to be really, really fast so that it doesn't impact the response time. So to accomplish that, what we have done is we have divided this whole process into two separate steps. One is what it creates the log record, the generation of the log record, and then writes it to a temporary storage or shared buffers in storage. And then a separate process which runs asynchronously will retrieve those records from that buffer and harden it into like DASD or tape or even cloud-based data sets. So here, let's go and take a look at these two processes in details. So next slide, please. Next slide, please.
This is the next slide, Rupak, recon log.
Oh, yeah, sorry, again, sorry. So we generate the log records using one of IMS's exit called RECON IO exit. The program name is DSPC-EXT0. DBRC gives control to this exit routine after successful completion of any IO operation to the RECON. Okay. So when it gives control to this routine, it also passes the record that is being updated as parameter to the routine. So we use this information and add other logging metadata like the timestamp sequencing, grouping, and all that, so that it looks like a log record that we can sort and perform other operations on. So once we have generated these records, we write it to a buffer and storage, and then we return control back to DBRC. And this ensures a short path length. We have done some benchmarking here, and it's normally in microsecond range, the whole process. This exit program, DSPC-EXT0, must be link edited with the DBRC load module, DSPC-INT0, and it must reside in the IMS REST live. That's the only requirement, and then you don't have to make any changes to your existing online system JCL or your archive JCL or image copy recovery chain JCL or any DBRC utilities. It's all, you don't have to do anything, any other changes except linking this BMC version of DSPC-EXT0 into the DBRC load module, DSPC-INT0 in the IMS REST live. So now we have written the generated log record to a shared data buffer. Then somebody has to retrieve that record from the buffer and actually write it to the to DASD or tape log data sets. So let's take a look at that. Next slide, please. Okay, so this is just a pictorial representation of what we just talked about. So you have the IMS region 1, 2 BMP jobs running, and then log archive, DBRC utility, image copy, or maybe change a queue, reorg jobs all running concurrently. And anytime any of these jobs updating the recon, or exit will get control and it will generate the log record and write it into the shared data buffer. So this is what we talked about in the last slide. So let's move to the next slide. So the logger region, this is the region which actually retrieves the log records from the buffer and writes it to a permanent storage. This is a separate address space, preferably an MVS starter task, and it should be initialized before any IMS system is brought online, basically really right after the IPL. So the purpose of this logger region is to, first it sets up the logging environment, It processes on the control cloud, so we'll look at that in the next slide. It allocates the shared data buffers we looked at earlier, where it writes those generated records. And it also initiates some MVS tasks for processing those log records. The function of it is to dynamically allocate the log data sets when there is any new log records to be written. It records the open time of the log record, and whenever it closes a log data set, either you request it to close it or you want to, or the log data set went full, so it will close it and it will record the close time of that log data set. It also handles, when the log data set gets full, it handles that condition. If you want to switch a log, basically you want to run a report or you want to run a recovery, you can force a log switch through a console command. All these are handled by this logger region. Obviously, we talked about it retrieves the log records from the buffer and writes them to the log data set. So anytime it updates or it allocates a new log data set, it records information about the log data set, like its name, its location, voltaire, and all that in a vsum data set. We call it directory data set. So this keeps track of all the log data set that's being allocated, its open time, its close time. If you created a backup of a recon data set, you can register it to this data set. It keeps track of all those records as well. And the main purpose of this is so that you don't have to remember any of the data set names that gets allocated. And it can automatically select at the time of recovery which logs it needs to bring in or which recon backup it has to bring in to run a recovery. So the logger region is really the one which does the heavy lifting of most of the work. Next slide, please. So, every site or every installation, you'll have many production regions and also you'll have some test regions. So you may not be interested in creating log information of test recons used in a test system. Or you may be interested in generating log data only for certain production recon. And the way you tell the logger region which recons to monitor and create log records for is through using profile. So a profile is a set of recon data sets. You tell recon 1, your recon 1, recon 2, and recon 3 data set. And since it dynamically allocates the log data set, you also have to specify or tell it what are the prefix of the log data set. We will append the date and time at the end of that. I think it's a 22 byte long prefix, and we add the date and time at the end. And you specify the allocation parameters, the space. If you have any SMS parameters, you can specify it in the profile definition. And the last two parameters in that diagram is the buffer size and buffer number. The buffer size is that shared data buffer we looked at earlier. So you specify the size of it in megabytes. So it's when you say buffer size 4, it's 4 MB. And you are requesting 4 of those buffers. These buffers can be either in a data space or it can be in 64-bit storage. Having them in 64-bit storage gives better performance. So right now we are using 64-bit storage. So when you create a profile, you give it a unique name, and you can have multiple profiles, but all of them have to have unique names, and you cannot share one recon between two different profiles. And same thing is also true for log dataset prefix. You cannot, the log dataset prefix name also has to be unique. So if you move to next slide, please. So when you initialize the logger region, this is how it looks like. It's pretty simple. RRF main is the main program. Specify the load library and IMS REST lib. Supply the directory data set, and then you specify the profile we just talked about. So you can have multiple profiles defined here. We showed only one, but you can have multiple of them. If you didn't define one, for example, when the region is brought up, there is a provision you can define them dynamically once the region is active through a console command. So we have a demo, so you'll probably see more about this when we play the demo later. Next slide, please. So this is the overall picture of everything we talked about so far. On the right-hand side, you have all the IMS jobs running. And on the left side in the logger region, you can see we have defined two profiles, profile number 1 and profile number M. So if on any of these jobs running on the right in green, like using profile 1, if any of them updates the recon, which will generate log records, we'll write them to the shared data buffer number 1. And then the log processing task will come asynchronously, retrieve the record and write them in the log data set. If it needs to allocate a new log data set, it will do that automatically. And as I mentioned, every time a new log is allocated or a log is closed, it updates the directory data set. Similarly, we have profile M. That uses a different set of recons. Again, if any of those jobs running that updates a recon, it will have its own shared data buffer. It will write those records in their buffer. And then it also has a log processor, which will retrieve the records and write them to the log data set. And if it has to update the directory data set, it will update the directory. The directory data set is common in between all the different profiles you use. There is only one data set. You allocate it once, and then that's going to be reused. And the log data sets, each profile will have its own set of log data set. There is no overlap. One set of log will only have information about one set of recons. On the right side in the middle, we have this IMS region Y or X. In yellow, that one, we didn't define a profile for that. So what happens since that exit program is in your step live? So first time any update request comes from IMS region X or Y, our exit will get driven. We'll look in the logger region, see if there is a profile that matches the recon that's used in IMS region X or Y. If we don't find a profile, then we'll disable the exit and return back to DBRC. And when you disable the exit, you don't get called again for that IMS. So this is the overall flow of how the whole thing hangs together. Okay. Next slide. The installation of this is very easy. As I already mentioned, all you have to do is link, our BMC provided DSPC ext0 in your IMS REST lib. And then you set up the logger region with appropriate profile definitions. That's it. As soon as the logger region is up, it will start creating log records automatically for any updates to the recon for the profiles you have defined. So it's pretty simple. Next slide, please. We talked about the directory data set, which keeps track of all the resources, like all the log files that got created, all the profiles that you used. If you register any backup of a recon, those are all recorded in the directory. So we have a directory utility program, which you can use to list the contents of the directory, as well as delete entries from the directory. So when you request to list contents, say, of a profile, you specify which profile, and then you tell what type of object you want to list, either it's a profile or a log or recon backup. And you can tell the timestamp. You can give an explicit timestamp using the keyword timestamp, which is not here, or you can give a range. It's a start time and end time, or you can just give a start time. So what it means is it will list all the records that matches this start time or falls within that start time and end time. Obviously, profile doesn't have a timestamp. So, that's timing or timestamp or start time and time really doesn't apply to if you are listing a profile, but it applies to log and recon. The delete command, you specify what object you want to delete in the profile name and the timestamp of that and object. And then it will go, if it finds it, it will delete it. In the list command, when you specify a time, you don't necessarily have to specify the exact time. You can give a generic time and it will pull everything within that range. But when it comes to delete, you have to give an explicitly complete timestamp for the entry you want deleted. In the delete, there are two other parameters, check, no, or yes. And it's a check, no, that means if it finds a match for the requested entry, it will go and delete it from the directory. If you say check yes, then it won't delete it. It will just report, okay, it's eligible for deletion. Then there is the option purge UI and purge no. When you say purge UI, along with deleting the entry from the directory, it will also delete the object. If it's a recon backup, it will delete the recon backup physical data set, the backup data set that matches this timestamp. If it's a purge no, then it won't delete it. So it will only delete the entry from the directory if we set purge. Check no. If you want to delete all the log records that's older than 30 days or 50 days, then you can code a different keyword called older than. So you tell which profile and the object you want to delete, and you say older than n number of days. So it will delete all the records matching that object that are older than 30 days in the directory. The object that you can delete using that older than is really the log and backup, recon backup. Those are the only two objects. I think we have a demo at the end, so you can see how that works. Next slide, please. Okay, so now we have created log record and recorded it in the log data set. We have updated the directory. So now time comes, suppose we have to recover the recon data set after a failure. So there are two ways you can run the recovery. One is backout recovery. What it does, in backout recovery, you start with the current recon data set, and then you apply the log records onto the current recon data set up to the selected or specified recovery time. So it's pretty straightforward. It starts with the current recon and apply the log records backward up to the recovery time. Also, you can also do a forward recovery. The forward recovery uses a backup copy of the recon dataset. It allocates a new set of recon dataset, basically copies the backup copy onto it, and then it applies a set of log records onto the newly allocated recon dataset. As I mentioned earlier, we have an utility. If you create a backup of a recon, you can register it in the directory using a directory registration program. What this gives, if you register your backups in the directory, at the time of recovery, you don't have to tell which backup to use. You can just tell, like, recover to this timestamp, and it will figure out which backup to use. It has enough information in the directory to figure out which backup to use, and then use that one. Next slide, please. So you already talked about it. If we go to the next slide, that's probably can go over it. So this is how the backout recovery looks like. On the left, you see you request a backout recovery by specifying which profile you want to recover. You specify the timestamp and you specify backout Y. That means you are requesting a backout recovery. If you say backout no, then you are requesting a forward recovery. So once you pass this keyword, the backout recovery program, it looks at the directory dataset, which is toward the bottom of the screen. And based on the timestamp, it automatically selects which log dataset it needs to run the recovery. It dynamically allocates those log dataset. Log reader will read those log records, pass them to sort, and the sorted log records are then applied to both Recon 1 and Recon 2. When you have processed all the log records, then the recovery is complete. So you have the recovered Recon 1 and Recon 2 dataset. You can start off with the production Recon that you have, or you can copy that into a separate dataset and then run the backout recovery onto the temporary dataset or the dataset you just created. Either way, it should produce the same result. I think there is also, you'll see it in the demo later. Next slide. The forward recovery is a little more complicated. It uses the directory information to select the recon backup and log data sets necessary to run the recovery. It dynamically allocates the selected recon backup and log data sets. You also supply the IDCAM's defined statements for the new set of recons. You supply it through a DD card, AMS PDS, and you should have some members there for Recon 1 allocation and Recon 2 allocation. So those are the IDCAM's delete statements, not delete, IDCAM defined statements for Recon 1 and Recon 2 allocation. So we'll use those and invoke IDCAMs and allocate those to two new Recon data sets. Then we'll copy the Recon backup onto Recon 1 data set. Then we'll start reading and sorting all the log records and then apply them only to Recon 1. When we have processed all the log records, then we simply copy Recon 1 to Recon 2. If you go to the next slide, please. Okay, so this is the same thing we just talked about in pictorial format. So same thing, only difference in the control card is profile, timestamp, and backout. Now you're saying backout no. So you're requesting forward recovery. So you see AMS PDS for new recon allocation under, yeah. So when recovery program starts, it validates the control cards and then it invokes IDCAMs to allocate those data sets, Recon 1 and Recon 2. Those are brand new Recon data set. Then it looks at the directory data set and selects which Recon backup it's going to use. Once it's selected the Recon backup, it knows the timestamp when the backup was created, and then it selects all the log data sets from that time forward up to the requested timestamp. So once the Recon backup is selected, it repros the backup Recon onto Recon 1. And then it will start reading the log data sets, ask them to sort, and then apply those sorted records to Recon 1. This process continues until all the log records are processed. Once done, then it simply copies the Recon 1 onto Recon 2 using IDCAM's repro command. So that's how you end up with, you've recovered your databases. Not databases, but Recon data sets, Recon 1 and Recon 2. Again, we have a demo for that. Next slide, please. Okay, so that's all I have for this. The highlights or key points is this is very easy to install. You don't have to make any changes in the JCL. Only thing is to link the exit, the IMS RESLib. The code path for the exit routine is minimal, and we don't expect any impact on the online response time. The tracking feature is active as soon as the logger task is initialized. And as we looked at, seen already, the recovery step automatically selects and allocates the Recon backup data sets and all the necessary log data sets. It's all done dynamically. You don't have to do anything. Keeps the recoveries job pretty simple. I think that's all I have.
Okay, thank you, Rupak, for the technical deep dive of how this new feature is implemented. Now I will invite Yogesh, who will take us through the demo of how
Sure.
this is done. So Yogesh, the next slide will be yours.
Thank you, Anshul and Rupak.
You started playing.
Am I audible?
Yes, yes.
Yeah. So now I will walk you through the demo of Recon Recovery Facility. So this is the demo JCL, and this is the demo profile which we have added. And this has profile name defined, then associated recon. So for demo purpose, I have only one profile which is defined here, but you can define multiple profiles and associated unique recons to each profile. So now in the screen, as you can see, I will start the logger region. So RRF demo is my logger region name. So I have started the logger region. So as you can see in the sysprint that your demo profile is initialized successfully with your recon, which is associated here. So once your profile is defined and logger region is started, then I'm here, I'm defining my recon in the first job and taking the backup of it. And in the second job, I'm updating the recon. So as you see in the control card, there are some DVRC commands which are getting executed. So we will execute these commands through this job, update job. This recon update job will track all the updates, and logger region will track all the updates. So as you see in the logger region, the corresponding log file is allocated. Then we have a forward recovery. So in the forward recovery, we have not yet registered the backup. So that's why we are passing the backup name here. So we have the program name, RRF recovery. Then we have directory specified. Then we have AMS PDS, which has IDCAM's definition for Recon 1 and Recon 2 specified. Then we have backup file specified. The backout is N, that means it's a forward recovery, and I'm passing backup time and the recovery timestamp. So let me submit this job. Once the job is submitted, it is waiting for the log dataset because it is holded by our logger region. So in logger region, we will switch the profile. So we'll reply to 1865 switch and the profile name, which is demo. So it says that your lock switch is processed successfully, and now your job is successfully completed. So we will go to the job and go to sysprint. Now we'll see the log information. So this has the control card which we have given, and then the bit recovery time which we had requested, then our directory dataset and the log file which was considered for recovery, and then Recon 1 and Recon 2 which was allocated from AMS PDS. And then we have log sort input phase and output phase which was explained by Rupak. So this is completed. And then it says Recon 2 dataset is copied from the Recon 1. And then it gives you the summary of record counts. So this is about forward recovery. Then now we will see about backward recovery, backout recovery. So in backout recovery, we will first copy our current recon to new recon, which we have defined. And then we will execute backout recovery with the same utility. We'll specify step lib, specify directory, specify recon datasets, and then we mention backout as Y in control card, and we will provide the recovery timestamp. Now, as shown on the screen, the job is submitted, it's completed. So we go through the sysprint. It says the control card, the directory dataset, the bit recovery timestamp, the recon datasets, and the log file which was considered for backout recovery. And then all the messages which are related to log sort input and output, and then the summary of record counts. So now, as earlier in forward recovery, we have seen without registering the backup, we have run the forward recovery. Now we would see how to register the backup. So I will take the timestamp, the backout timestamp, and I will use this timestamp in registering the backup. So this is the backup registration, and I will specify the timestamp, specify the recon dataset, and I will submit the job. So now our backup is registered. So now when you check the sysprint, and it says that your backup is registered to the directory, and now we will run the forward recovery again. So this time I'm not passing RCN backup DD statement. So it would read the backup information from the directory. So I am just passing the timestamp and submitting the job. Job is completed. Now we will see the sysprint. So again, the same details about our card, and then information about here. This informational message is extra that recovery will use recon backup copy, and then the log dataset details, and then log input phase and log output phase messages, and then the summary of record counts. Oh, as Rupak already mentioned about how to link edit it. So this is the job for link edit with the DSPC and TH0. So you need to specify your REST lib, your BMC lib, and you specify the card and submit the job. So that's it. So that would link your DSPC and T0, and you will be ready for using RRF facility. That's it from my side, Anshul.
Okay, thank you, Yogesh. And I just wanted to mention that this feature is already available and went live in October timeframe. And all the customers who are having a valid license of BMC AMI Data for IMS backup and recovery set of products, this feature comes along with that, and they should have it already. And if any of the customers are interested in knowing more about it, they can obviously reach out to us. Okay, Matt, it seems like we don't have any question as of now. Obviously, as mentioned, if you have some questions later on, you can reach out to us, and this uh, will also be available on demand for those who have registered for the event. And we are also planning to upload this session on BMC IMS, community's YouTube channel, so that way it would be easily accessible. But yeah, we highly recommend customers to start considering this feature and reach out to BMC if they need more details and need a hand holding to implement this feature. Okay, thank you everyone for attending today's webinar, and have a good day.